Hello and welcome to day 8 of Advent of Code 2024. In this puzzle, we have a map or a grid system that is like this. As usual, the dots means empty spots and all the other characters in the map represent a antenna. The antennas with the same character, so these ones are the ones that are basically providing the same frequency. So these four are providing the same frequency and these three are providing the same frequency. Now, for each two antennas with the same frequency, there is going to be like two antinodes that we need to find. Now, antinodes are the spots in the grid that are in line with the antenna. So if we draw a line from here to here and extend it in this way and in this way, so it would be something like this, the antinodes will lie on this spot. But where? That is exactly twice the distance from one and once the distance from the other. So if we say, for example, the antinode is here, then the distance from here to here will be twice the distance from here to here. The same way, we will have another antinode here, which would be like twice far from this than from this. And again, it should be on the line with these two antennas. The next point is that some antinodes might land on top of other antennas. That is fine. And we need to find all the antinodes that are unique. So if like these two provide the antinode here and these two provide an antinode here, then we need to count it only once. Okay, so here are the examples that you can go and read by yourself. But let's get to the code and see how it was implemented. Now, in part 1, we have a grid that is like this. We split the data as usual by new line. Then I'm going to create the antennas. Now, I would loop through the grid and check the position that I am currently in against the dot. If it's not a dot, then it's a antenna. So we would start from here and would go to here and then come here and go to here and do this and do this. And when we get to an antenna which is like this, we would say, okay, this is an antenna. For this antenna, we need three things to save: the character or the frequency of that antenna, so that we could match it with others, and this X and Y position. That is basically done here. Great. So after this for loop, we would have all the antennas in an array. The next thing is that for each of the antennas, I would compare it against all the other antennas and find the antinodes for that antenna. So let me get a simpler example. So for example, like this. I would get this antenna and say, okay, find on the antinodes where this is the point A and all the other antennas are potentially point B. So from here I would check this again against this. I will say, okay, this is a match, both have the same frequency, so there can be an antenna from here to here, so it would be somewhere around here. With this and this, there would be an antenna antinode around here. From here to here, there will be some here, and so on. And then again, for this one, I would check this against all the other antennas. These three will be discarded, and from here to here, there will be another antinode here. From here to here, there will be another antinode here. And you can see, going like this, for each of these two antennas, we can find all the antinodes. The one that is on the left and the one that is on the right. And one thing else is that when the antinodes fall off the grid, so they land here or here or here or here, we need to discard them. So if we go back, you can see that I have two for loops for these antennas. Now, sometime we would compare the two antennas that are the same, so we need to reject that, we return. And if the antennas are not from the same frequency, which means that the character is not the same between the two, we need to return, we don't do anything. Otherwise, we calculate the distance between the two So like this, the distance from between these two, and then we create a new point. Say, okay, this is my A, this is my B, calculate the distance and then add the distance to this, so we land on here. Okay, so this is the new point. Then the thing that we do is check the new point against the grid. Does it fall out of the grid or not? If it falls out, we return. We don't do anything for this specific B with this A. Otherwise, we add the antinode to the set. And I use set here because I want to discard all the duplications automatically. Okay, then I would return the size of the antinodes to see how many antinodes we have in the grid. So this is part 1. For part 2, it gets a bit more interesting. Here on part 2, according to the example, the antinode for two antennas on the same frequency like these two can occur anywhere along the line of these two antennas with the same distance from the antennas. So for this one, let's say the distance is this much, so anywhere along this line with this distance there can be an antinode, so it would be here, and it can continue going on. So from here it would be here, here and here, and also here, because we can go along this line this way as well. So for all the pairs of antennas, both those antennas are antinodes, and all the other points that are on that line and are the same distance from, and are the same distance that is the distance between the two antennas. I hope this is clear now. So for these two it would be here, here and here. For these two it would be here, here, here and here. And again we need to find all the unique antinodes, and we need to count these only once. So let's go and see how we can implement this part. So if we go here, the antennas, getting the antennas is always the same, doesn't change anything specific here. But for the antinodes, again we would have 2 for loops to match all those antennas with each other. Again, if they are the same or they don't have the same frequency, we just return, we don't care. Now the distance is the same again, but now for the new point we need to start from the start antenna. So we would find these two. We say, okay, this is point A, and from here all the points along this line that are this distance that we found here are antinodes. Then we get to the new point. We say, okay, new point is now A. So this is my new point, but I would not add it to the set yet. From here I would get the distance. I have the distance, which is here. Then I would say, okay, from here add the distance to get to the new point. If that new point is in the grid, then add it to the list of the antinodes. So from here we go to here, add it, go here, add it, go here, add it, go here, add it, and then go out of the grid. So that is implemented here. We add the dy and dx to the new point, which is A in this example. Then if this is out of the grid, we return or break. Otherwise we add it to the set. And obviously if we are here and we count all of these, so from here we count this, this, this and this, but when we get here and we match against this, we need to only count this. And for example, for these two, if I am starting from here, I would add these two antinodes, and if I'm starting from here, I would add this single antinode. And this way we would get to the answer, which is just logged down here. So I hope you've enjoyed the video. If that's the case, don't forget to subscribe to the channel, and see you in the next one.